All members of the Mississippi Section phone net. This is Whistle 5 X-Ray net field session located at the trademark in Jackson, Mississippi, at the site of the Capital City Hamfest.
Hi, I'm George.
I'm Tommy.
We're here for, I guess it's episode 19 of AmateurLogic.TV, and we're at the Capital City Hamfest here in Jackson, Mississippi. Tommy, what's on your shopping list for the Hamfest this year?
Well, I got to get my usual bag of PL259 connectors for sure, and I'm looking for some kind of a portable HF antenna to set up for my travel trailer.
Cool. Well, I've got a few things on my list too, mostly small items, some connectors like you said, some insulators, a ballon, just a few little odds and ends.
Yeah, it's not a Hamfest without a bag of PL259s.
Yeah, you're right about that. All right, well, let's go have a look. We're walking around here just looking for familiar faces and characters and such at the Hamfest, and look who I ran into.
Wonder who it is.
Hello, Wayne.
How are you doing, George?
Pretty good. We've had a lot of comments from the folks about the MFJ footage that you shot earlier this year. As a matter of fact, I was talking with Richard a while ago over at the MFJ booth, and he said they've had a lot of comments about it, too. We really appreciate you coming along for that and helping out.
Well, I'm glad I could help. I'll be glad to do it again if need be.
All right. Well, don't run away then. We may need you here in a few minutes.
Okay, sounds good.
All right, I found a rig here, a TS430. I bought one of these at the Hamfest last year for $250. It was an excellent deal, and that's what I'm going to pay for this one if it works. We're going to go to the test bench and check it out. Yeah, probably pushing that power supply. Let me try a couple of them. Go ahead, do it again. Well, I appreciate it.
Always warm up. That's what we're here for. Glad you got that chance on that.
And I run across another familiar face here at the Hamfest, Richard Stubbs. Richard.
Hey, George. How's it going? Nice to see you.
Good to see you again. We've had a lot of folks comment on the videos we shot at MFJ.
We have, too. We've been down to Florida and St. Louis, Missouri, and people have commented on your videos, and they say how professional your show is, and I have to agree. I was real pleased with how that turned out.
Well, we really appreciate y'all hosting that event there and allowing us to come in and tape some of it, because people all over the world have been watching them, and we've really got some good response. And
it's great. I mean, I appreciate it more than anything, and we hope to tie that into our website soon. We're just getting a little lazy there doing it. So.
Well, we hope you will. You know, any publicity for either of us is a good thing.
Yes,
so.
Sir.
All right. Good to see you, and hope you have a good Hamfest here.
Good to see you, George. Take care of yourself. All right.
This is what's referred to as boat anchors here, some old Collins gear. And I'm not real familiar with these units, but, man, they look immaculate. They look almost like they just came off the showroom floor. Some guys would really like to have this stuff here. I wouldn't mind having it either, but I don't have a big enough shack to keep it in. We're talking with Ev N5MZX here of the Flying Pigs Association. And what does Flying Pig specialize in?
Fun, fun, fun. We have no dues, no rules. If you don't like what we do, we'll change it. And we are the fun side of the amateur radio group. We're an internet club, solely internet. It was founded in 1999 by Diz Gentile and some other, he was W8PIG, great call. And the Flying Pigs is basically an in-your-face thing to QRO folks. When we would talk about working so many different countries, the QRO operators would say, "Yeah, when pigs fly, guy." The Flying Pigs are known to do a lot of crazy things. And my wife said that when I leave here, I'll go back to the insane asylum and I can come back tomorrow on pass. Membership is open to anybody who lives within 12,000 nautical miles of Cincinnati, Ohio. That's the only qualification. If you're alive and breathing, you can be a member.
Okay, so I see you've got a number of, I guess these are home-built rigs here and kits. We see the Altoids 10. Tell us a little bit about that.
Well, we've had some of our members bring in kits that they've built. This is an absolute homebrew 40-meter transceiver that was built. And if you'll notice the paint job, it's the old Heathkit paint scheme, which is great. This is a Small Wonder Labs SW30, which is one that I've just recently built. This key right here is a home-built paddle that's used with this radio. This is a Rockmite transceiver with battery pack, and this is an old Radio Shack enclosure. All right, over here, this is the L-Craft 20-watt dummy load, which is an excellent kit for somebody that wants to start building. This is a Talo SWR bridge. You either have a good SWR or the LED lights. When the LED is out, you're cool. I mean, you're ready to go. This is my favorite kit of all. This is a frequency mite PIC-based frequency counter.
Okay, it's a PIC microcontroller in there.
That's correct. And it can be integrated into any of these transceivers by setting the settings on it, or it can be used as a standalone frequency counter. Here I have an old MFJ 207 SWR analyzer, which is basically an oscillator, and I'm using it to put on here. If I push this red button, you'll have the frequency read out in Morse code.
That's pretty neat. How much does it cost to build that frequency counter?
This is a little $20 kit. Wow. And the Altoid 10 was bummed. One of the things we're going to try to do this year with the registration packet, in every packet there's an Altoids 10. Next year we want all our participants to either home brew a rig or build a kit. Whether it works or not, bring it back here. We're not judging anything. Anybody who attempts to build a kit, we're going to throw their names in the hat, and we're going to have a nice kit like an SW30 or an MMR 40 to give. We're trying to promote kit building and bring back some of the old-time amateur radio into a appliance world.
Well, I like building stuff myself, so I might have to take you up on that offer. I've got a lot of old Altoids 10 saved up right now. Some I've already built things in, but that's a great idea.
The Altoid 10, the cockroach of amateur radio enclosures. So they're cheap. Everybody at work donated these 10s I'm giving out this time. We're giving out 75 of them, and hope to have that much response next year at the Hamfest.
I'm sure the folks at Altoids are proud to see you coming too.
Oh yeah, and of course everybody's breath is much better too, So, but they make a great enclosure. You can get other 10s. I've seen them in little craft stores that you can use. Jim N5IB last year had all the fine wooden enclosures, which you saw last year. There are just any number of ways that I have a Coors 2.5 liter keg at home. I'm debating on putting a radio in. So, we have fun with nothing.
Thanks for talking with us,
Thanks
Seth.
a lot. I appreciate it, and you got a great show.
Well, thank you. We're talking with Bucky Greer here at WB5LXZ. Bucky, good to see you here at the Hamfest.
How you doing? Glad to be here.
Tell us about this gear.
Well, this was General MacArthur's personal radio on the battleship Missouri at the signing of the armistice in World War II.
Wow.
And if you believe that. No, this is some real classic equipment that's kind of hard to find now. This is an SX-28, it's a World War II radio, and very popular, probably the top general coverage radio that we had during World War II. Yeah, Hallicrafter SX-28.
Well, it really looks clean.
Yeah, this is the Collins 51J4, very, very rare. Just can't find these anymore. Didn't even see one at Dayton. This one's complete with all the filters. And nice radios. This is a Hallicrafter SX-42.
I've seen a lot of these in old movies.
Well, this went on the worldwide expedition, famous expedition around the world in 1947. And this particular model did. Very, very popular with Hallicrafter back then. These are all general coverage receivers. Amateur shortwave bands. So they've all been restored, except this one. This one's original. These have all been restored.
Of course, all these are tube-type gears, and most hams would really like to have them.
And you can take them home with you tonight.
No, looking at the prices, I really can't tonight.
Package deal. Maybe tomorrow. Yeah. We'll see what happens.
Thank you, Bucky.
Thanks for coming by. Yeah.
I'm Ed Lowry, N5XN. We're out of Baton Rouge and out of the Amateur Radio Society at LSU. So what we're going to talk about today is working with surface mount. And just small is better. It works out great. This is a typical little SMK1 kit. It was put out by NorCal QRP a good while ago. I don't think you can order it anymore. But it was a chance for people to first get their hands wet with SMT because everybody's so worried about surface mount products. They're too small, you can't do it, you need really special tools and whatever. And it's not the case, as we'll see today. So we're going to start out with a surface mount project from start to finish. So this isn't a kit deal where you run out to NorCal or somebody else or the Flying Pig guys in the North Georgia Club and buy a kit. This is you're going to build your own PC. Lay out a PC board, build a PC, lay it out, etch it, and then start mounting parts on it. We'll show you how to do that. So we're going to do a schematic diagram, just a real quick thing, a circuit board layout, and we'll go through the whole etching process, and you'll actually see the board etch, and then we'll prep the board and get it all ready for the surface mount component installation. So we've laid out a little simple board. This is one of Jim's M5IB's projects for a little RS-232 interface, just a simple Max 232 level converter and a few chip capacitors, and a little header coming off of it. So it's a very simple project. Now, really simple tools to do-it-yourself PC boards. An iron, just a standard household iron. Actually a dumb iron. You don't want a steam iron, quite frankly. It should be variable temperature, though. We're going to use the toner transfer method, so we can use a laser. You can't use an inkjet printer, but we can use a laser printer or a photocopier. Jim likes to use, in particular, press and peel. Press and peel is a specific blue paper that's made for this process by the Technics company. It's fairly expensive if you think about a sheet, 8.5 by 11 sheets, about $1.25 a sheet in quantities of 5. Get a little bit cheaper as you buy a pack of 10 or a pack of 20. A pack of 20 would probably last the average ham 3 or 4 ham lifetimes at least. What he's going to do then, once he gets this neat blueprint out of his circuit, he's going to take a piece of PC board. Now notice he's got 4 of these little circuits, it's real small. He's got 4 of them built on this one piece of copper, and then he'll cut it at the end to have all 4 units. So take that, really needs to be absolutely clean. You want all the oils and finger oils off, handle it with the edges of the board, scrub it really hard with plenty of Brillo rubbing and Comet or something that's abrasive. It'll really clean and shine up that copper and get it spotless. Clean it all off because you're still going to have a little bit of oil, even for the residue from the Comet and all that kind of stuff, or a Brillo pad. So clean it all with a little bit of alcohol or a little bit of acetone and let it evaporate off very quickly. Then you're going to place that transfer film with the toner side down. In other words, you've printed on it by the printer. You're going to flip it so that the toner side is touching the copper, and you've got a little sandwich there. And you can see the whole size of this thing. That's a dime in the foreground. You want to use a fairly hot iron, and you have to experiment with this. You're going to mess up a couple chances here when you first start out, depending on the iron you use. Once you've got it down to, I've used this iron before and I know what to do, you probably will get yourself in trouble if you're using the wife or the girlfriend's iron. So generally doesn't ruin the iron, but you could, so be careful and go invest in one. You do not want a cotton setting in this particular iron that was shown here works pretty well, but you do need to experiment, and you don't want to use steam. You're going to press a piece of paper. Steam is going to turn into water, right? And you don't want that. You're going to have a mess on your hands. So what we typically do is also put a piece of paper. You've got that little sandwich of the press and peel material. Now that press and peel I mentioned a while ago is kind of expensive, and you don't have any today, and you need to run down. And I know when you leave here, you're probably going to leave the Hamfest and go run home and build a PC board. Just the dying need to do that, and you don't have any press and peel in the place. This is the place you can use your QST magazine sheets or any other glossy, slick type of magazine. Cut a sheet out of that thing and use it and print right on top. The ink that's already on that won't matter. It's only going to be the toner that's on top of that that'll actually work. And people do that all the time. It's a cheap way to do it. And it's a place to use 78% of the magazine, since it's mostly advertising, right? Buy yourself a little cheap piece of glass or a mirror, something like that, that'll work really well. And it's going to be absolutely smooth. It's not porous at all. It's going to really work out. Just keep it clean. You don't want bumps in this thing. So what you're going to do then is take this with modest pressure, move that iron over that whole sandwich area for about 5 minutes. And you can experiment with your time and your iron and your temperature, as it goes. So once you finally get that done and you let the board cool for a few minutes so you can really handle it, because it does get warm, you can just start running cool water over it. And as you run that cool water, it's going to start loosening up that blue paper or whatever paper, the QST magazine paper, whatever. Just kind of start teasing up an edge of that paper a little bit, and then run water behind the paper in between it and the board, and it'll slowly but surely you'll be able to separate that entire piece of film or paper right off the board. At the end, you should have a fairly nice, clean pattern ready to go to do our actual etching process. Here's your chemistry lesson for the week. I know you knew you were going to come to a Hamfest and get a chemistry lesson. Most of the time, you've probably done in the past, if you've ever done any PC work or school or whatever else, they've used ferric chloride as the etching solution. We've kind of gone to a case of using 2 parts of just standard drugstore hydrogen peroxide. It's 3% solution, so nothing special here. Get it from any Walmart, the Walmart drug area or whatever else. And 1 part of hardware store or pool supply store of muriatic acid. Muriatic acid is actually, it's a 30% solution of hydrochloric acid. Now you do need some precision equipment to measure this stuff. You need some kind of little bowl to do your etching in, and you need a really precision measuring device. It's probably the hard thing to get. A little pill bottle will work just fine. So you don't need much. It's all 2 parts to 1. It's not exactly 2 ounces or whatever else, simply 2 parts to 1. Any little measuring device will work right here. So the precision thing isn't really necessary. Do it outside, just as a safety thing, so if you knock it over on the floor, you're not going to get beat up by the loved ones or whatever. And also always make sure you put the peroxide in first, followed by the acid. Standard high school chemistry lesson there. The process took around 10 minutes, and as you can see, from nothing to the board going into the soup, starting to prep itself, and suddenly you see a little bit etching, a little bit more etching, and slowly but surely we've etched off all the copper except for where that blue tone, it's not blue anymore, it's just the toner, and the paper is still there. And the toner that's been transferred to the board. So now we have a really neat PC board. Now where we've protected everything, we've got that toner on there, right? So we need to clean that toner off because we want to solder to this board, and we're not going to do very well through that toner. Acetone, just standard nail polish remover. You can buy jugs cheaper rather than buying acetone in a bottle. Buy a can of it in the paint supply areas of most of the Home Depots and things, and Lowe's, and then you can buy it for a couple bucks and get a quart of the stuff. Everybody needs a funny-looking goose-shaped surface mount holder down or doofus. We should all say that at one time, but you'll all. Now that's what that is, a funny-looking goose-shaped surface mount holder down or doofus. Got to have something to hold these parts because you're going to try to hold solder in one hand, a soldering iron in the other, and you got a part that's sliding around on the board, right? So nothing more than a little bamboo skewer. Jim loves this model of the guy, and I've actually brought one, left it in the car because we got so delayed with trying to find an extension cord today. But you can also bend one completely out of some piano wire or something other. But this is just a little skewer. He files off the end a little bit, so he has a little flat surface there, a little sliding fishing weight on it, and you can either glue that or just have a force fit, and just a hot glued piece of stiff wire. So for installing 2 terminal components, we want to tin, like we said before, especially on a homebrew board, we're going to tin our pads. This is blown up. There's not a lot of solder there, but it's blown up pretty big. If you have a pair of tweezers, you can use that to hold and position your part to get it in place. And of course, you can after you lay your part in place, use your doofus, right? You got to have a doofus to hold that part in position over the pads, and then solder one end, take your doofus away, and solder the other end. Just light touch of solder. Now, when you're starting to install components with many close space leads, there's 3 ways of doing it. You can do it the careful method, you can do it the slobber and clean method, and you can do it with the paste reflow method. You may want to, at this point, tin at least one corner, like pin 1 of a chip or something or other, just one of the corners, and then go ahead and solder it in place. Then you can get the doofus out of the way, go ahead and solder the other opposite corner, and then after that you can take your time and just apply a little bit of heat. And typically I try to apply heat down here to the, at the trace level, right at the base, down far away from the pins, and then let that solder wick its way to the pin. Or you can use the slobber method. Now, normally the slobber method is a discovered method. You went to do the clean method, and you turned into using enough solder to build 2 or 3 houses. It's a big welding job. And you find out, oh my God, I have put solder all over every pin in this thing. So we want to clean that up, take that solder wick, and if the solder wick has turned dry on you a little bit, you can always take and kind of reflux it a little bit. That's the cheap way to do it. Don't run down and buy some more. If you've got some wick, go ahead and smooth out a little bit of that flux on it to get it so it'll draw better. And then you can clean that up to make it look like that. Now, we have the third method is the solder paste or the reflow method. Yeah, let me show you this process here. Now, this is a little embossing gun, heating gun case. All he's doing is spraying hot air. And slowly but surely, you kind of watch, see how that started flowing out? As a matter of fact, the AmateurLogic guys who are taking the video today, they did one of these for a demo and showed the parts. And some of the parts, if they're even crooked, they'll automatically just snap themselves into place. It's really cool. It's not cool, though, when it snaps itself in place, but it pulled itself over to another pad. Right? I saw that one, too. Wise man once reminded us all, you get what you expect what you get, no matter how screwy you look. And that's Jim examining a board. Check your work very, very carefully. Like I said, those parts could move over. It might have, when you move even moving the board to get it in position. So even no matter how nerdy you are, use a magnifier and check your work. Okay, just real quick and wrap up. This is an ATS-3A. I mentioned it before. I think there's a 3B model out now. It was developed by and designed by Steve Weber, 81JV, the consummate QRP developer. And this is the one over here to the right. There's actually 2 kits. This is the NorCal FCC1, which is a frequency counter. The other side of the card actually has a LCD, an LCD readout that's really, really nice. Very accurate freak counter up to maybe 40, 50 megacycles. So when it comes to surface mount components, as you all know now, the only thing we have to fear is fear itself.
Yeah, what is this thing right here with the paper tape?
Graph that was used probably the 30s, 40s, and 50s is used for Morse code instruction, etc. If you notice, the tape has little holes punched in it that matches Morse code characters. And as it's pulled through the caps in here, it trips the little arm off, and it gives you your dots and dashes you're looking for your Morse code. Now, this particular model has got an audio amplifier built onto it. Therefore, you don't have to add an external amplifier. It'll automatically generate the tones for you. Now, this model down here is, really, this is a telegraph model here with a 3-post. Same thing here, only rather than using an electric motor, you wind it up like a Victrola. Wow. And you got your speed regulation. Let's slow it. I don't have the tape on this one, but the same principle worked on this one here. Now, somebody did get a little ingenious, and they put an old vacuum tube in the back of it, however.
That's for the amp?
Uh-huh. You put your headphones on that.
And this
radio down here is an old Viking 1. That's what you call a boat anchor right there. And I've got some guys from Alabama wanted it last year, and I told them I had one at the house. I said, bring it with me this time. So I did.
I don't really have a well thought out, insightful presentation, but I'm Andy Anderson, WB5TTE, and I've been afflicted with the ham bug for a number of years. I think probably about 77 was when I got my first license. Did a little CB before that. I do everything backwards myself. I was a Mars operator in Vietnam, working with Collins equipment and great big amplifiers and great big antennas long before I ever got my ham license. So I kind of backed into it. Then I came home, realized what I could afford, and started out with a kit. But what is ham radio? It's a hobby. It's a service. It's licensed by the federal government. Lots of people are hams. You'll be surprised. We've got doctors and lawyers and bankers and business people and students, automotive technicians, and just a lot of good people. Some of the things we do, we have nets, and we talk on the repeater weekly, monthly, different nets. We have clubs. Personally, the things that I really enjoy is I like contests. I really enjoy public service events, and I'm up to support any kind of emergency. You know, I've always fallen out to help whenever there was a tornado, hurricane, or something of that nature. I spent several hours at FEMA during Hurricane Katrina, trying to get people off of roofs and all that kind of good stuff. You can collect cards and try to make DX contests. But ham radio is so much more today. It's not any one thing. Some of us still enjoy Morse code. We have moved into the digital age. There's a lot of opportunities for people that enjoy computers more and want to operate digital. There's a number of modes, PSK, PACTOR, different modes. That doesn't mean much to you if you're new, but they're out there. You type on your computer, it comes up on the screen. You can see the other person's call. It's really an interesting mode. It's fast-paced and it's real clean copy, and it's a little more impersonal than talking to someone. Some of us just like to rag chew. Get out there and find a friend and talk to them. And we also have repeaters, 2-meter repeaters, to talk locally. There's a lot of very interesting people you'll meet in ham radio. We have a few with us today. These gentlemen put on some great video, and it's out there on the web, and you can download it and enjoy it at your leisure. I've sat many a night from 1 to 2 watching AmateurLogic.TV, and I'm glad to have George and Tommy and Peter present those shows. That's just great stuff. I wish there was more like that out there. I brought a couple pieces of equipment to show you. The radios have really gotten smaller over time. My first one was much bigger than this. This is a HF up through 6-meter and 2-meter in this small radio. And this is one of the things that I've really started enjoying a lot recently, as I had my granddaughter, 9 years old, to help me put together these little QRP rigs. She would put the parts on the board and I would solder, and we spent a couple enjoyable hours putting together each one of these, and believe it or not, they worked. It was quite a thrill to make a contact with something you just put together with a piece of wire strung through the living room, laying over the couch. A long time ago, you had to really work hard to get your antennas adjusted, and you had to have a big tuner and dial the capacitor and set the inductors and all of that stuff. But now they've got these auto tuners, little small boxes that you can plug into your radio, and it'll take care of most of the complicated adjustments. So ham radio has really changed for the better. I'd hoped there'd be some young people here today. I had brought an old keyboard that you can type on, and it sends Morse code if anyone's interested in that. But you don't have to learn code anymore. That was one of the biggest stumbling blocks for me, and that's why I was probably through with college and out of the service and all that before I got my license, because code was very hard for me. It took me years to get it mastered, and I'm a long way from being fast now. But I do enjoy it. I enjoy it more now than I ever did, and I think that's what they decided, that if we could get people into the hobby, that they would find something they enjoyed, either public service, sending code, just rag chewing, all these different things I mentioned. I need to tell you that there's 3 license classes. It doesn't take an awful lot to get started. 50 questions, I think, is the number on the test. Several ways to learn how to become a ham. You can get some of the ARRL publications and read the training manuals. The one's called Tune in the World. There's other groups that have training material. There's the Gordon West people that have some series, W5YI. There's stuff on the web, QRZ, that you can go through and just take the test online till you get familiar, and then come to a test, a session. And there's probably a test session almost every month somewhere in the area. We have one at the Red Cross about every month or a couple of months. I know that there's one in Hattiesburg coming up. I just heard it on the evening net. So they're not too hard to find. You may have to go a few miles, but there are people that are willing to take their time and give you the test, and then they're willing to go and help you set up a station, spend some time, get you started, show you the basics, and it's really not that difficult. So if you have an interest, come talk to us. We'll point you in the right direction.
This radio right here comes with 2 bottles of amplifier smoke. We're talking with John, KC5KWZ. John, you're a viewer of AmateurLogic.TV.
Yep, I've watched every episode.
Oh,
I have watched every episode.
Well, we appreciate it. Has it inspired you in any way?
Oh, yes. I built the Soft Rock 40 kit, the transmit receive version, and I'm getting ready to test it out soon.
Well, great. I'll be glad to hear how that works out. Let me know.
Okay, and I'll if I can, I'll try and send you a report on that.
Oh,
maybe some video.
There you go. Yeah. And yours is actually the transmit and receive version, unlike the one I had. So it'll be good to see how that works out.
Right. I'll be interested to see how it works out, too.
What was the hardest part of building it?
Winding the coils and making the transformer.
Yeah,
that was the hardest thing.
That was my hardest part of it, too. So did you use a hot air method, or how did you solder?
Oh, no, I used just a regular solder iron. Hopefully it worked out. All the voltages and all checked like they're supposed to, and the resistance they tell you to check for is well there, so hopefully when I fire it up it'll do something.
Well, great. Well, thank you for talking with us.
Now, the antennas that 99% of the people use today, a few more than that probably, are the basic wire antennas that Mr. Hertz developed in the late 1880s. Actually, before that a little bit, but somewhere back in there. And then James Clerk Maxwell did a bunch of theoretical stuff around 1880 something or another, and set the basis for the theoretical work. Well, all these fellows that go to study antennas in college, then that's their Bible. Well, unfortunately, I don't totally understand some of the mathematics involved in that, curls and divs and all those kinds of things. And so I have to look at things from a simple viewpoint. So I thought you fellows might appreciate a simplistic view of what antennas really are. In its simplest form, it is a capacitor in series with a resistor. Now, the resistor is actually what we call the radiation resistance. Now, an antenna has a resistance, and depending on its configuration, that resistance will vary. The theory says, okay, you put a dipole in free space, got 73 ohms resistance. If you put a vertical up, it's half of that. I mean, those are some rules of thumbs, and those don't even hold very close either, because there are a lot of variations of that theme. Now, the capacitor is actually the capacity between the two elements of the antenna. In the case of a dipole, it's the capacity between the two elements. In the case of a vertical, it's the capacity to ground, or theoretically, it's the capacity to the radials. But the radials are the other half of the antenna. Now, when you look at the antenna, in order to be able to pass current through that radiation resistance, you have to have a resonant antenna. A couple of ways to get that. One is that you build the antenna basically a quarter of a wavelength long if it's a vertical or, a half-wave dipole. And that means the inductance and the capacitance are equal, and therefore they cancel out, and therefore you can put maximum current through that radiation resistance. Well, That's the simple theory. Now, let me just allude to that a little bit more, and that is that when you have an antenna, as you pass current through that antenna, the current will develop a magnetic field. Now, the magnetic field, as it changes, in other words, as it increases or collapses, it will create an electric field. This is the basic concept of a generator, alternator, whatever you want to call it. So you pass current, you make a magnetic field, and that in turn creates an electric field. Now, unfortunately, those two fields are really 90 degrees out of phase because one created the other. Now, I might also comment that an electric field, as it collapses or increases, will generate a magnetic field on that same piece of wire. So this thing just goes back and forth. One of the unfortunate things about an antenna is that you have a very large electric field surrounding it because the electric field and the magnetic field are 90 degrees out of phase. In order for the thing to radiate, they have to be in phase. In other words, they have to occur at the same time. Now, basically what happens is that as the electric field propagates, it propagates slower than the magnetic field. And when you get out to roughly a third of a wavelength from the antenna, they caught up with each other and they're basically now in time phase and they start radiating. Now, you can get deeper into it and say, well, okay, now the electric field and the magnetic field are always going to be orthogonal to each other. And that is that one of them will be, if you will, vertical, the other will be horizontal. And now this gets you into, okay, what kind of an antenna do you really want and what kind of purpose do you want to use it for? Well, we all know that a good vertical antenna has a low angle of radiation along the ground, and that's a good thing for some applications. On the other hand, a dipole, if you stop and look at that, the current's going along the wire, and it creates the field such that it's up. So a horizontal antenna makes horizontal polarization, we call it, and the radiation then is perpendicular to the antenna, and therefore your horizontal antenna radiates straight up. Now, depending on the height of the antenna, in the case of a dipole, you wind up with what we call a pattern that's a function of the ground. In other words, if you put it at a quarter of a wavelength above ground, there's two signals coming out of the antenna. Just a signal, but it surrounds the antenna. Okay, so, but think of it as two signals. One of them going straight up, the other one going straight down. Well, the one going down is going to hit the ground, and it'll turn around and reflect off of it and go back. But now, if it's a quarter wave above ground, then that quarter wave goes down, turns around, comes back 180 degrees for that traverse in there. The quarter wave is 90 degrees, so half wave would be 180. Now, you get into problems where the radiation patterns can cancel depending on where the antenna is located. So generally we like to have a dipole for maximum high angle radiation to be a quarter wave above ground. If you put it at a half wave above ground, it turns out that you get almost complete cancellation, and therefore there's no high angle radiation, but rather your maximum signal now is at lower angles. But now you got another problem. The problem is that a signal that propagates along the ground will actually be absorbed if it's a horizontal polarized signal. In other words, a dipole is a lousy antenna to go along the ground. On the other hand, if you turn the antenna vertical, and if you build either a vertical or a vertical dipole, it is not absorbed by the ground in the same way, and therefore you get good low angle radiation out of it. So that's why you use a vertical antenna for AM broadcast. Now, if you want to get on 80 meters or something, you're really not going to be talking to anybody locally, so to speak, on ground wave. What you want to do is go ahead and propagate at a high angle and let it come back down, and you will get good communications around the area. Now, by the same token, if you want to talk more than about round number, 750 miles, then you really ought to be using a vertical antenna to get a low angle radiation out there at that distance. And that's about where the two cross over, where you have the signal from the vertical or the horizontal antenna will cross at roughly 750 miles. So for the longer haul stuff, you need a vertical. For the short haul, you need a horizontal. That says, well, now, let's think about that for a minute. Let's talk about 20 meters, or 10 meters, or 15, or whatever. So all of us put up a great big old beam antenna, a great big horizontal beam, and we wonder why we can't talk to somebody. Well, the problem is it's a horizontal antenna. The horizontal antenna tends to have a higher angle of radiation. If you get that horizontal antenna high enough, it will begin to give you a pretty good low angle radiation. But if you really want to work some DX, take that horizontal and flip it vertical, get that low angle radiation, and go out there and chase that DX with it. Now, on the other hand, you say, well, that seems to be a bit of a problem. And the problem is that it's a mechanical problem. You have the antenna, how do you turn it up and work it with the tower? Well, the tower is going to cause you some mistuning problems. So what you have to do is retune it for that. But if you'll do that, and as a matter of fact, if you look around, I don't see it much anymore, but back in the heydays of CB, what'd they do? They had vertical antennas, right? But there again, the CB was predominantly local stuff. So they really got good propagation along the ground. And then they found out, hey man, we can work DX. So now the CBers get on and talk all over the world with these vertical antennas. So they figured that out a long time ago, but most of the hams never got around to thinking that way. So if you really want to get out there, go use a good vertical antenna. And if you want a whole lot of gain out of it, just go ahead and turn your beam up so that it's vertical, and then away you go. Well, that has some mechanical problems, but hey, you know, everything's got a problem somewhere, so you got to trade one of them for the other. The theory, though, that if you really look at and want to look at what propagation looks like, you have to consider your antenna being somewhere above ground, and it's going to have a signal that's direct, and you have another signal that reflects off of the ground. Now, those two, if they are additive, that's a good thing. If they subtract, that's a bad thing. Well, now, if it's a horizontal antenna, they tend to subtract, whereas if it's vertical, they tend to add. And this has to do with the dielectric constant of the ground and all that other fancy stuff. The point is, though, that, again, if you want low angle, use a vertical. You want high angle, you know, to talk 75 meters around the local area out to, you know, rag chew out to a couple of 300 or 400 miles, use a good horizontal antenna. So that's the basis of deciding what type of a system you really want.
We've run across another familiar face here at the Hamfest. Hello, Mr. Jew.
George, how are you today?
Oh, doing pretty good. Did you have a good Hamfest?
Jackson is always just a really nice Hamfest. We always enjoy coming up here.
Well, great. We've had a lot of comments on the tours of the factories, and we still thank you for letting us go in and have a look at all that.
Well, we appreciate y'all coming down and doing that. Y'all did just a super job, very professional. Got a lot of comments from those who watched it, too.
Well, thank you. We're going to be doing some more segments on some of your products here in the future that I think people will be interested in seeing, particularly the antenna analyzer.
Oh, well, that would be great. I know lots of people would like to know some of the other things it can do other than finding SWR. That would be very useful to a lot of hams.
Well, I'm interested in seeing that myself, so that's one reason we're doing it, just to see what all can be done. All right. Well, good to see you. And have a good Hamfest. All right, I'm buying this amplifier for Jimmy since he couldn't be here today. $350 for a Yaesu FL 2100B amplifier. That's a deal.
That's a good deal. Thank you.
Thank you. And Tommy is texting Jim right now to tell him that he's now the proud owner of an amplifier.